In this video, I will demonstrate and explain how to add an external encoder to the Sigma-7Siec controller for 1.5-axis operation. Hi, I am Micah Studeman. Here's a quick preview. The full closed loop and feedback option cards can be added to the Sigma-7Siec for 1.5-axis operation. This operation typically is used for applications that deal with camming and gearing. To enable the external encoder for the 1.5-axis operation, parameter pn00e.3 needs to be set with the proper rotation direction. When enabled, the external encoder can be used as an electronic gear master. Now let's look at this in a little more detail. Part of the IEC controller lineup is the Sigma-7Siec controller. This Sigma-7Siec controller is a single-axis Sigma-7 amplifier with an embedded controller that allows it to be programmed using MotionWorks IEC. This single-axis controller follows the IEC 61131-3 standard, just like the MP3000 IEC series controllers and the MP2600 IEC 1.5-axis controller. The Sigma-7Siec controller comes in either the 100V/200V style or the 400V style. This single-axis controller has 7 digital inputs and 4 digital outputs available for application use. Amplifier firmware version 0024 and controller firmware version 3.7.0 adds functionality to the Sigma-7Siec controller. This allows an external encoder to be used to provide 1.5-axis control. 3 option cards are available that can be used for 1.5-axis operation on the Sigma-7Siec controller. The full closed loop option card is one option, and the others are the feedback option cards, which come in 2 variants. These option cards are purchased separate of the Sigma-7Siec, and you as the user installs them. They do not come pre-installed from the factory. Looking at the full closed loop option card, it reads rotary or linear position information from Yaskawa certified encoders. These encoders use the Yaskawa serial protocol to transfer position data. Supported linear encoders can be found in the Sigma-7 technical supplement under the Introduction, Related Encoder section. One rotary encoder is available using the Yaskawa serial communication. The encoder cable used to connect the full closed loop option card with Yaskawa serial encoders can be found in the Sigma-7 technical supplement under the SGMMV and relay encoder cable sections. The option card uses the same encoder connector as the Yaskawa Sigma-7 amplifier. The feedback option card is used to read rotary or linear position information from third-party encoders. The Type 1 feedback option card supports the use of sine-cosine, hyperface, and NDAT encoder protocols. The Type 3 card only supports the use of TTL encoders. To use any third-party encoder with the feedback option card, a manufacturing file needs to be created for that encoder and loaded into the feedback option card. The encoder cable used to connect the feedback option card with the third-party encoder can be found in the Sigma-7 technical supplement under the CN1 I/O peripheral cable section. The feedback option card shares the same connector as the CN1 connector on the amplifier. The main use of 1.5-axis control is for dual feedback operation. The dual feedback setup uses the external encoder to control the operation of the motor through electronic camming or gearing. Consider the following diagram of a rotary knife mechanism. The conveyor belts are being driven by an induction motor running separately from the Sigma-7Siec controller. The external encoder is the master device, and the Yaskawa servo is the slave device. The external encoder, connected to the Sigma-7Siec via the full closed loop or feedback option cards, reads in the conveyor's position and calculates the speed of the conveyor belt. The servo motor is connected to the rotary knife that is cutting the material riding on the conveyor. I'm going to go through and build a dual feedback application to show how to set up the Sigma-7Siec controller for 1.5-axis operation. For this example, I will be using the Type 3 feedback option card, but the full closed loop and Type 1 feedback option cards can be used in the same way. The master device is going to be a TTL quadrature encoder connected to the Type 3 feedback option card. The slave device will be a Sigma-7 motor connected to the Sigma-7Siec single-axis controller. In the MotionWorks IC project, the MC gear-in block will be used to gear the two devices together. The final outcome will show a one-to-one gearing application. One rotation of the master, the external encoder, will equal one rotation of the slave, the servo motor, and both will rotate in the same direction. These option cards are ordered separately from the Sigma-7Siec controller and need to be installed on the Sigma-7Siec. The option card installation guide is available on Yaskawa's website, along with the product manual for the feedback option card. The general installation guide is also included in the option card box when ordered. After the option card is installed, the servo pack can be powered up and initial settings can be performed in MotionWorks IC. I am online in hardware configuration with a new project, and the controller is currently set back to its default configuration. The hardware tree displays the integrated servo axis. To enable the dual feedback external encoder functionality on the feedback option card, I need to go under Axis 1, go to All Parameters, and parameter PN00E.3 needs to be set to either 1 or 3. When turning on the use of the dual feedback encoder, the positive direction needs to be specified for the encoder. For this example, the encoder rotation should be the same as the motor rotation. If I look at Axis 1 again, and go to parameter PN00.0, I can see that the motor's rotation is set to counterclockwise for the positive direction. So if I go back to all parameters, through testing I have found that setting 3 gives me the desired result for the encoder rotation. I can now do an online save and reboot. After reconnecting in hardware config, Axis 21 will now be available in the hardware window. This is the external encoder that is connected to the feedback option card. Looking under the resource, I can see that there is an alarm, and it is an A.CF1 alarm. If the full closed loop option card was used, the alarm would not appear. This alarm is there because there is no manufacturing file in the Type 3 feedback option card. This file needs to be loaded using Sigma-1 Plus version 7. Loading the manufacturing file can be done after hardware configuration has been set up. Going back to the external encoder access, the encoder being used is a TTL, otherwise known as an A quad B rotary encoder. The encoder spec sheet shows that the encoder is 13-bit, so the resolution in hardware configuration should be set to 2 to the 13th, which is 8192. The feed constant needs to be set equal to the motor encoder's feed constant so that visually, one rotation of the external encoder will rotate the servo motor one rotation. So if I go under Axis 1, I'll see that the feed constant is set to 360 and the user units is degrees. So I'm going to go back to the external encoder and I'm going to set the feed constant to 360. And set the user units to degrees. Another online save and reboot can be performed. The full closed loop option card does not require a manufacturing file, but for this example I'm using the feedback option card, so a manufacturing file needs to be loaded using Sigma-1 Plus version 7. Contact your local RME to work with you to create the manufacturing file, otherwise known as a .mgf file. This file is specific to the encoder that is being used. The encoder resolution needs to be provided to the RME along with the encoder type for the Type 1 feedback card, so they can create the manufacturing file. Open Sigma-1 Plus version 7 and connect to the amplifier using the USB connection. For this example, I am using Sigma-1 Plus version 7.32. Looking at the product information inside Sigma-1 Plus, I can see that there is no feedback option module information for the encoder. That is empty, so that is why a file needs to be loaded. To load a .mgf file, go under Main Menu, go under Encoder Settings, go to Motor Parameter Scale Right, A message will appear basically saying that it's going to be rewriting the scale file, so if there's any wrong information, it could cause issues in the motor's operation. I'm going to hit OK. To load the actual manufacturing file, I'm going to hit Reference, select the file I want to load. Then I'm going to hit Next to go on to the screen that allows me to actually write it to the amplifier. Now down here, this is all the information that is included in the file. So there's a picture, and the type of encoder being used, and then some remarks for the encoder. So I'm going to hit Write. Another message appears basically saying, are you sure you want to write this information? I'm going to hit Yes. Sigma Plus version 7 is going to then basically say that it can't write the file, even though it actually did write the file. So for right now, I'm going to select the function as ended without executing writing. Now the message is going to appear saying that it's not written, even though it is. I'm going to hit OK. And then a hard reboot can be performed. To verify that the encoder file was written, you can go back into the main menu, go under Product Information, and now under the Feedback Option module, you can see the information has been placed there for the external encoder. Over in MotionWorks IEC, here's the code that will electronically gear the external encoder with the servo motor. The external encoder is set as the gearing master, and the servo motor is set as the slave device. The current motor encoder and external encoder positions can be seen in the watch window and are currently set to 0. If I go over to the demo, rotating the external encoder wheel rotates the servo motor. Looking at the watch window, one revolution of the external encoder rotates the servo motor one full revolution. And as you can see, both rotate in the exact same direction. High-speed sensors are used in these types of applications for taking position information of registration marks. Referring back to the rotary knife diagram, let's say that a sensor is added before the knife. This sensor is used to capture registration marks on the material so the knife's position can be adjusted for the cut. This sensor comes into the CN1 connector on the Sigma-7Siec controller. Looking at the Sigma-7Siec I/O diagram in the product manual, it has 3 digital inputs that have high-speed latch characteristics. These inputs can be used to capture the sensor signal. For this example, I will use EXT1 as the external latch trigger input, which is pin 10 on the CN1 connector. To show that the Sigma-7Siec controller can capture the external encoder position using a high-speed latch, I will use the MC Touch Probe function block in the MotionWorks IEC program. A toggle switch connected to pin 10 on the CN1 connector will latch the encoder position. Executing the MC Touch Probe function block, I can rotate the external encoder and toggle the EXT1 input to capture the external encoder's position. The captured position can be seen in the main window of MotionWorks IEC. One important note is that the Sigma-7Siec controller can only have one MC Touch probe executing at a time. Multiple MC Touch probes can be used to latch encoder positions as long as they are not active at the same time. For example, in the one-to-one gearing application, both the external and servo motor encoders can latch positions. For this to occur, one touch probe has to be executed, and then I can rotate the encoder, and then latch that position. Then I can go over to the second touch probe, execute it, rotate the motor again, and then latch that position. Simultaneous triggers are not supported on the Sigma-7Siec. Thanks for watching this video. For more information, visit Yaskawa.com.